everyone. Good morning, students, family, and guests, and welcome to UMW. We're happy to have you as admitted students joining us this evening. We are in the meeting module of Zoom, and the session is being recorded. So if you don't want to be seen or heard, please turn off your video and mute your microphone. You may enter questions in the chat box, and we'll also be leaving time at the end of the meeting to answer any questions. So feel free to put any questions that you have as we're going or at the end. I'm here as an admissions rep, so if you have any admissions related questions, I'll also leave my email below so you can go ahead and ask anything, but I'll go ahead and turn it over to the folks you're actually here to talk to tonight.
All right. Hi, so I'm Varun Makhija. I'm a professor here in the physics department at UMW. So I think we'll take at most 30 minutes of your time. Our students, Drake Richmond and Margaret Gregory, will go after me, and I'll take the first 10 or 15 minutes just to give you a brief intro of what physics here is all about. So I'm going to start by sharing my screen with a little presentation. So on this slide, you can see a bunch of different pictures. This right here is something we call a nebula. It's basically the remnants after the explosion of a star. It's up way up, far, far away from us. It's a picture taken by the Hubble Space Telescope. This thing here is a giant wave in the ocean. This thing here is a aircraft taking off, a fighter jet taking off. That's the iPhone 12. This is a rainbow, and this is an artist's rendition of a black hole. All of this stuff is somehow related to physics. It's all something that a physicist, somebody like me, could study if they wanted to. That seems weird. So I think before I tell you a little bit about physics at UMW, it may make sense to just tell you what physics is. What is this thing that encompasses all these different things, from an iPhone to a black hole to ocean waves to rainbows, all of that stuff. And it's a hard question to answer, but you can think of it as a little like a constitution for nature. Kind of like all the laws in the United States are fundamentally rooted in its constitution. They all have to somehow abide by that constitution. Physics is a list of statements about nature that any other laws we learn about nature have to be rooted in. They have to abide by those set of statements. So I don't know, if you've done chemistry in high school, you may have studied things like Boyle's law, Charles' law, the ideal gas law. All of those things have to somehow start at this constitution, at this small list of statements. And that list of statements is basically what physicists work with. You can basically think of these statements as being answers to the following three questions. What is stuff made of? And under the hood, when I say under the hood, I mean, what are the basic Lego bricks that nature uses to construct any and everything? And there are actually only 4 kinds of these. There are only 4 kinds of Lego bricks that nature can stitch together using 4 different types of glue that physicists call interactions. Nature stitches these Lego bricks together to make absolutely everything, to make me, to make you, to make tables and chairs and oceans and mountains and stars and galaxies. It's all the same 4 basic Lego bricks. And then we obviously need to ask the question, well, if it's that simple, how does absolutely everything, startlingly different things, the iPhone 12, a black hole, how do these 2 startlingly different things all follow from this same constitution? This last part is what most physicists spend their time on. Some physicists are still adding statements to our constitution. And understanding this last part actually helps us do stuff. I'll give you an example. One example is one of these Lego bricks that we discovered is called the electron. And this is the thing that is responsible for electricity. Electricity is essentially just this sort of sludge of electrons just sort of slowly squeezing through wires. That's what's happening when you turn on a light bulb. A sludge of electrons squeezes through a wire. That same sludge of electrons squeezes through the filament in a light bulb. And then the electrons in the sludge slam into stuff inside the light bulb. And that slamming in is what produces light. So the reason why physics is important is because this number 3 point allows us to do useful things, like make electricity, make heat, things like that. All right, so now that we have some idea of what physics is, I can tell you how you could learn it at UMW. There's a couple of choices. We have 2 physics majors. One is just called the physics major. In that major, and the physics major is what the 2 students here, Margaret and Drake, are doing. You will see all the pieces of this constitution, and you will learn how to apply these pieces to do stuff. There's another one called the applied physics major. Here, you will also see most of the pieces of the constitution. In fact, you will see all of them, but not as deeply as you would if you took the physics major. And you will then also learn how to apply specific pieces. So you will go more in depth into certain pieces in the applied physics major, but you will learn all of them at a base level in a sort of broader way. So that's a rough difference between the 2 majors. The physics major is what you would do if you intend to do things like go to graduate school in physics, and you can do more with it. I'll talk a little bit more about that. The applied physics major is a slightly more flexible version. If you wanted to study engineering or you wanted to study medicine, the applied physics major would probably be the better choice. The most important thing about both majors is either can get you a job. And I'll talk more about that in a bit. Before I talk more about getting you a job, there are some practical skills that any employer or any graduate school wants you to have. How would you get those practical skills at UMW? The way you do it is by doing research in physics. So UMW has some unique research facilities as far as physics goes. We have something called a femtosecond laser. I won't say much about this other than tell you it's the laser that's used to do eye surgery. We can talk more if you have questions about this. Very few schools like ours have this facility. In fact, it was built by one of our students. Here, if you can see that, that's a picture of one of our students, Henry, actually physically building the laser. This was our Christmas card in December. The other thing that we do is, so this laser is used to do atomic and molecular physics, which is what I do. That's my field of research. We also collaborate with labs around the country and around the world. Stanford University is one of them. Stanford University has, this is a picture, has a 4-kilometer long X-ray laser, which also has many, many uses, and we use it. In fact, at the end of this month, I will be doing an experiment at that laser. Margaret is involved in that to some extent, and if we were not hit with COVID, we would actually be there in the last week of February. All right. Additional research you could do. We have a visiting professor, Dr. Rasha Makia. She's a medical physicist. One of our students is currently doing a research project on medical imaging with her. And we'll have a new faculty member joining in fall, who will be conducting some kind of fundamental physics research. So this will be a person who is adding statements to that constitution. I don't do that. I actually just use the laws of physics to learn some interesting things. So I'm sort of in between applied and fundamental. Dr. Makia is fully on the applied side. She studies medicine, and the new faculty member will be fully on the fundamental side. So you kind of have a spread of choices as far as research goes. And doing research will build your practical skills. You will learn how to code. You will learn how to work in an actual work environment. So all of these collaborations involve us working with the other workers at Stanford University or other workers at UVA and stuff like that. You will learn how to write papers. You will learn how to do technical things. In some cases, learn how to work with electronics. In some cases, like Henry here, learn how to work with lasers, which is an important technical skill in physics and engineering. So that's what the research will get you. You can do the research through something called the UMW Summer Science Institute, which again is a pretty unique thing that UMW has. Most schools our size don't really have such a thing. What this is over the summer, the school will provide you housing and a summer salary to participate in research that some of the faculty are doing. Margaret can talk more about this if you'd like. She did it with me last summer. So now back to the actual getting the job part. I said either major will get you a job. Well, how do I know? So I thought I'll share some of our recent track record with you. These are just names of recent graduates from UMW. All of them have the traditional physics major. The applied physics major is a new thing that we've begun. But here are some of the things they're doing. This right here, this is AJ. I put AJ here because he's somebody I knew while I was here. That's his daughter, Melody. AJ is a atypical student. He was in the Marine Corps for 7 years before he came to us. And then he was a physics and mathematics major. He graduated in 2020. He's currently working at Naval System Sea Command, which has a number of labs in the Virginia sort of area, Maryland, Virginia area, that hires numerous of our majors. We have a good connection with them. So he works in submarine and ballistics there. Logan Cass, another one of our majors from 2020, is also working at NAVSEA Labs. We do have majors who apply to med school, and I'll talk more about programs in medicine in a second. And Stephen is currently a PhD student in mathematics at Lehigh University. I'll also talk a little bit more about grad school in just a second. And Vidya is a master's student in medical physics at VCU. And finally, we have another student, Hannah Killian, from 2019. So I'm just going about 2 years back. This list is very long, but this just goes about 2 years back, who is doing a master's in electrical engineering at UVA while working at NAVSEA Lab. And I'm pretty sure they're paying her way through that master's degree. That's our recent track record. What about our current students? So I'll talk about our students graduating in 2021. Specifically, let me talk about the one student that's on this call. That's Margaret. There she is. She's holding a cricket bat. Cricket is a sport. That's about all I'll say about that. So Margaret decided to apply to a number of PhD programs. And here's a list that she's been admitted into. MIT, University of California, University of Colorado, Purdue. These 1, 2, 3, these 4 are some of the best schools for physics in the country. And LSU was her backup, which she got into as well. She's also cleared the first round for something called the Fulbright Scholarship. We'll know probably in the next month or so if she clears the second round, which gives you, X amount of money to go do some research at a place of your choice. So that's Margaret. We actually only have 2 students graduating this semester. The other one is Shannon. I didn't put Shannon's list here because Shannon still doesn't know which school she's gotten into. She is applying to get a master's degree in medical physics, which you probably saw from the last slide. Our students do some medicine. We won't know which school she's gotten into for another month or so because they are on a later application cycle. So I'm pretty sure she'll get into all her choices as well. So basically, I'm trying to say we have a pretty decent success rate for both grad school and jobs. One additional thing I do want to say about grad school. You can ask Margaret about this if you want, because she now has the option to go to one of these great places. You might ask, well, why the heck would you want to spend more time studying, right? And you might ask, why would you spend more money, right? You're already spending a fair number of tuition dollars on your undergraduate education. The thing about grad school is you don't pay, you get paid. Go to graduate school in physics. Graduate school in physics is basically a job. You will get paid to either teach for the first year you are there, and then you will get paid to do research. You will be a working scientist when you are in graduate school. So tuition is not a worry if one wants to go on to graduate school in physics. What you can do with a PhD in physics is actually more expanded than what you can do with a bachelor's degree in physics. And if you'd like, I can talk a little bit more about that. All right, so that's the class of 2021. Something more about an option that is recently become available for physics majors at UMW is a joint master's program with George Mason University. And that's a master's program in engineering, and you can specialize in one of these subfields of engineering here. An advantage of this program is that in your last year at UMW, you will actually be placed in a number of master's level courses at George Mason. And those will count towards your degree at UMW and towards your master's degree at George Mason. So it's like getting an early start on the master's degree. I will say, full disclosure, this is not one of those programs that pays you to go. This is a program that you do have to spend tuition dollars on. But it is something worth considering. A master's degree in engineering is a strong degree to have. All right, that's pretty much all I have. I'll let the students, Margaret and Henry, take over now. I wanted to put all our contacts on the page for you. Feel free to send any of us an email. That's me there. There's also the chair of our department, who's a professor of chemistry. That's Janet Asper. That's her email there. And Margaret and Drake, who will tell you a little bit about our Society of Physics students and would also be happy to answer any questions you might have. All right, let me share screen on the presentation for Margaret and Henry. All right, you guys can take over.
Okay, I guess you know by now, but I'm Margaret, and I am the president at SPS currently. And I'm going to start by telling you what it's like being a physics major from a student perspective. And then Drake's going to take over and tell you more about SPS and what we do. And we have a question. I will actually get to this answer in this slide, my next slide. Okay, so what is like being a physics major from a student's perspective? As far as the types of work that we have to do go, it is pretty challenging, but I think it's fun. I enjoy it. I think Drake will say the same thing. Most of our students really, really enjoy the work that they're doing, thus they stay in the major. There is a good bit of math, but again, don't be intimidated. Your professors are definitely there to help you learn it if you don't already know it. And a lot of us end up being double majors in math and physics just because they go together pretty well, but you don't have to be by any means. And then another thing that I think is a highlight of our department is the student resources. So we have a lot of support from our professors and our fellow students, and we are encouraged to collaborate on our assignments when allowed, and office hours are readily available if you do need extra help outside the classroom. Something we're doing now because of COVID is we have a Discord. So all of the students can get together outside of class and help each other with the homework, which is really, really helpful and pretty cool. And another thing I think Drake wanted me to say, we don't need chemistry. So a lot of the science majors, a lot of them require chemistry. So if you're afraid of that, you're intimidated by that, but you still really enjoy STEM, come check out physics. We're a really good option in that case. And then this is answering the question about the courses. Some of the courses we have include quantum mechanics, classical mechanics, E&M, which are all required, but we also have electives such as astrophysics, medical physics, and thermodynamics. And astrophysics was actually a course that the students really wanted. I was in it, and we wanted it for years. And finally, when Dr. Makisha came, he agreed to teach it for us. So everyone was really, really excited. And I think they want to teach it again as well. And something that I like about our university is that students sometimes have a say in the electives that we get. So this semester, we were all sent a poll, and it was, do you want thermodynamics, medical physics, or quantum field theory? So we all voted, and we ended up getting thermodynamics and medical physics. But it's just kind of cool that we get to have an input on what we want to learn. So I think that's a really neat thing. And then, like Dr. Vroon said a little bit, there are a lot of opportunities for research involvement and internships. I'm doing research with Dr. Vroon, so is a lot of our students, actually. Most students in our department do research before they graduate, which is a really good way to learn. And it's just another aspect of our major. And I guess the last thing, adding on to the student support, the student community is pretty close-knit here since we are one of the smaller departments on campus. And one of the things that students really get involved in is SPS, which is the Society of Physics Students. Yeah. So overall, the Society of Physics Students, we have a chapter here at our university, and it's just a community of physics majors and other people interested in physics. So we have a lot of members aren't actually physics members. They just want to hang out with us and have a decent time. We watch movies. Now due to COVID, we do a lot of things on Zoom, but we've had astronomy nights pictured here, which are always a lot of fun. And we were also trying to build a trebuchet. as one of our activities, and we have all of the materials, but due to COVID, we weren't able to build it when we bought the materials. So if you do come here, you can be a part of that. You can help us build the trebuchet, which is pretty exciting, I think. Yeah, and I think our emails are here as well if you want to email us after with more questions. But I think I'll turn it over to Drake now to talk more about the activities we do to have inclusion and stuff like that.
Thank you very much. Also, hello, I'm Drake. I'm a sophomore physics major here and the current treasurer of the SPS. And so I want to talk about a little about partly what we have done in the past, which is much more extravagant than most recent events just due to the virus. But you can see a couple highlights here. We host regular colloquiums, which are physics talks about all sorts of things. The one pictured here is from Dr. Makija about his atomic ultrafast pulse laser research. And to the right, this was from our trip last year, we toured UVA's graduate level atomics physics labs. And there was a lot of really interesting machinery and equipment that we saw and experiments that they had set up. And it was really nice to get the insight of a potential that, or for somewhere that we could go after this. And I think our department is starting to work with UVA on some level. That's not important. Anyways, picture below, we have in the middle is from when we went to see we went to a book talk by physicist Brian Greene. I'm sure some of you know him from his TV series or somewhere else. He's very famous. And then on the far right, we have a couple of our members at PhysCon, which is a huge national convention for all sorts of physics things. And the Dr. J. Bell Burnell discovered the first radio pulsars, which is pretty interesting, and they got to meet her. So there's a lot of exciting opportunities there. And on the left, you can see a summation of a lot of things that we hold recurringly and things that we've done in the past. We have semi-weekly club meetings, do homework help, and also since we have a Discord community now, it's just a running thing for whenever somebody needs it. Game nights, we've had potlucks before, and our trebuchet project, which has been in the works, and on the horizon is potentially something involving rockets. Don't have too many details on that, but we have regular colloquium series, which are held virtually now, which I enjoy, but there's a lot of really interesting material there and a lot of really distinguished characters and scientists who come and give talks to us. We're really grateful to have them here. And so, yeah, we've done a couple field trips before, the Brian Greene one being I think my favorite out of that. And our advisor is Dr. Makija, and he's very good at giving us advice on careers and guidance. Oh yes, and this is a bit more of an up-to-date list of our activities. On the left, you can see is our shirt design for this year. We haven't done shirts previously, but we had these last 2 years, which is exciting. We all voted on a design, and the winning one was the Cubic Earth Society. And below it, you can see those are all of our officers this year. We attended a talk by Dr. Ken Ono, who was a consultant to the movie The Man Who Knew Infinity about the mathematician Srinivasa Ramanujan. And that was really fascinating. And another one that we had last year was the senior director or something of Amazon's cloud computing services, and he gave a talk on quantum computing, which was really cool. And you can see a abridged list of topics that we've previously discussed, or I'm sorry, have had colloquiums on. Molecular laser physics, nuclear physics, medical physics, which was fascinating to me. Quantum computing, responsibilities of a scientist, a citizen, which I really liked because it was more, never mind. I'm going to get sidetracked. And then what about X-ray lasers and a couple of their applications? And the middle of this slide is just memes, view at your discretion. But yeah, so we work really closely with our department, and you don't have to be an SPS to be involved, you know, with a lot of physics things. We're just here to be a community that is really cool to be a part of.
All right. So that's basically all we had to tell you. I'll just reinforce what Margaret and Drake said. One of the strongest aspects of our physics department is the community. I know I spend a lot of time with all the physics majors, and it's a lot of fun. Our faculty are very involved with all sorts of things that we try to do to help them out, career advising and stuff like that, but also just, I'm there at almost every SPS thing, for instance. I'm there at the game nights. I'm there at all the talks. So it's a pretty close-knit and strong community, and there's a lot of support for you if you are a physics major. Yeah, I think that's about all. There was a question, but I think Margaret addressed it a bit. I love astrophysics. How many astrophysics? So we definitely have the one astrophysics course, the one that Margaret mentioned. There are also 2 introductory astronomy courses, which are broader courses. They're meant for, they're usually taken by non-physics majors, but a physics major could definitely take it. If you're a physics major, the course you would take is astrophysics. And we are working on basically building a astronomy and astrophysics stream of the major, in which, you know, and the astrophysics course will be one of the ones that will be a required course in that case. If you have any more questions, feel free to ask. So Olivia, if there are no more questions, do we just stick around?
I think since there are no more questions and all the folks who we have signed up have already kind of shown and talked with you guys, I think you guys are all set to go ahead and wrap up. Thanks so much for being here, and thanks to the admitted students. It's really exciting that you guys are admitted and kind of looking forward to UMW. So it's so exciting to have you here. Thanks so much, and thanks to the lovely hosts too.
Sure, I think we did get a question.
Oh.
So yeah, so one of the facilities you saw was the femtosecond laser lab. That's my research space. Other than that, we have several teaching labs. We've got one advanced lab in which you will spend a lot of your time when you take a course in advanced experimental methods. In that course, you basically are given a bunch of equipment and asked to figure something out. So we'll ask you a physics question and you'll have to answer it with the equipment given. So in that course, you learn how to use, amongst other things, you learn how to use lasers, something called an oscilloscope, various kinds of standard laboratory equipment that is expected for somebody who is in a physics lab to understand how to use. So that's our advanced lab, which basically has a fair amount of top of the line physics equipment that you will learn how to use. And we have 2 introductory lab spaces in which you take the introductory lab courses, which are basically, they are paired with a lecture course. So the introductory physics course is a lab and a lecture course. And those lab spaces, you won't yet be interacting with all the advanced equipment. But you will still, the spirit will be very much the same. It will be a spirit of inquiry kind of situation where you'll be given some equipment, not sophisticated equipment, and be asked to answer a physics question. So those are the lab spaces that we have for teaching. We also have 4 research labs. Currently, I'm occupying one. Our new faculty member will occupy another one. We have 1 research lab that is dedicated to student research projects. So often our students will come up with projects that we don't think of ourselves. When that happens, we have a research space for you, which you can work in. It is equipped with things like, there's a hardware cabinet with a bunch of tools in there. There's several computers in there. There, at this point, I think, is a tea kettle. I don't know why that's in there, but the last student who was, the last project that happened in there was a student who was a double major in physics and music, took the body of a harp, which was somewhat broken and it couldn't be used as an acoustic harp, and wired up the entire body with laser diodes so that it could be played as a digital harp. She graduated and she's now a graduate student in the music program, where she's doing the same kind of thing. She's taking broken instruments and rebuilding them into a digital instrument. But anyway, so there's a room for research projects that students come up with that is dedicated space for students. And there's also a dedicated theoretical research lab, which is basically a room filled with computers, which is, again, dedicated space for students. Those computers can be used for a problem set that you may encounter in class, because we do a fair bit of coding in our classes. And those computers can be used for parts of your research project if you need to do any computer coding for your research projects. That room is also the place where most physics students, and actually me, we like to congregate there when there's no COVID. That room also has a tea kettle, it has a refrigerator, and it has a microwave and stuff like that. It's kind of the hangout space. Yeah, so those are all the spaces, and you can ask Drake and Margaret. As a physics major, you pretty much have free range of our entire floor. If you need to be let into a room that for some reason your key card doesn't get you into, I will let you into that room. They are currently actually both in their own separate lab spaces. Drake is in in the advanced optics lab, and Margaret is in the general advanced physics lab. So they're both in advanced lab spaces right now. I hope that answered the question. And also, I guess you saw in the astronomy, in the pictures, we have several really nice telescopes, which we take out during astronomy night. So if you were interested in looking at the stars and looking at the moon, we have 2 automated 10-inch telescopes, which we take up to the roof of GW, which is one of the bigger buildings that has a big roof. And we stargaze. The plan there, well, so far we've stargazed only within the physics department, but we were gonna get some hot chocolate and popcorn ready and invite the entire UMW community to come and stargaze, have open stargazing nights. Our first one was planned the week COVID hit us, so we unfortunately didn't get to do that. But planning for that is starting again. We hope to now be able to take small bunches of people. Like we'll offer, we can take 5 people up to the roof for stargazing on night X, and we'll have people sign up. But yeah, that's another thing. We have tons of astronomy stuff, telescopes that we use. The picture you saw of AJ with his daughter, we were actually watching the transition of Mercury across the sun, because we also have sun filters for all the telescopes. So yeah. Happy to answer any more questions if there are any. maybe we can just hang out for 5 or 10 minutes. If you think of a question, just type it up. All right, perfect.
Looks like our other student just popped on out too. So thanks so much again for being here tonight, guys. And this is going to be recorded, and I think we'll eventually work on putting it up on the website. So people who weren't able to come can kind of see all this good information later too. Thanks so much, guys. Have a good night.
Thanks, Olivia. See you. Bye-bye.
Bye.